right. Hey guys, so I know this is the last talk of the day, so I'm happy that you guys stick around for it. This is going to be non-technical and it should be pretty short, so it should be worthwhile to listen to it. And hopefully after the end of this, you'll get inspired or maybe the insight to change a little bit of your data analysis or data reporting techniques with a little bit of the stuff that I'm going to be talking about here. So to start out, who am I? Well, my name is TJ Nelson. I'm a researcher for Arbor Networks. We do DDoS mitigation for some of the largest networks around the world. My Twitter's handle is REOnFleek. So if you want to ever hear about malware, I'm usually posting something about that. Shout out to B-Sides Charleston and CHS InfoSec group. Those are two groups that I run in Charleston, South Carolina, which is where I am from. And on the day-to-day, I do a little bit of malware reverse engineering, and then I also track botnets, mainly DDoS botnets for my company. But none of that is what I'm really here to talk about, because some of you may have something in common with me, and that is you're a recovering incident responder. So yes, I spent 7 years doing incident response consulting, which meant that I was the poor sap that had to fly out on every IT guy's bad day and tell them what was going on in their environment and how to fix it. This was really tiring. It's a very hard job, but someone has to do it. And at the end of your engagements, when you're helping them solve the problem, you have to give them recommendations on how to not have that happen again. Now, you know where I'm going to go with this. Most of the time, you're going to give them 10 recommendations, and you'd be happy to see 6, 7 of them actually get done. And that's really frustrating because you know that a couple months later, you're going to be around and they're going to be doing the same exact thing. And you're going to be like, I told you so. If you're a security practitioner within a company, I'm sure the same type of things happen to you. So you're usually working on a project. They tell you, oh, tell me a little bit about this. And is there something going on over here? You do the analysis, you give them the data, you say, these are the problems. And then 2 months later, those problems are still happening. And you're like, why did I spend so much time learning all this stuff and working on this when nothing's going to happen? So that's pretty frustrating. And it happens all the time. I mean, even when you talk about the DNC hack, I think if you think about it, the FBI called the DNC 5 months before they actually were able to find the threat, and they gave them a warning, but because there was just no intention spent to that, they actually didn't see what was going on, and that's where a lot of the problems came from. So while I was an incident responder, I took a lot of that time to try to realize and understand why no one really listens to the great advice that we give as incident responders. We're telling people how they're doing stuff wrong. So why won't you just listen? And I realized that a lot of it is that they don't really understand what they're dealing with. They don't understand the data that we're giving them. And a lot of it is basically sort of fear and doubt and fear, doubt, and uncertainty for them. And they don't really want to take in some of the stuff that we say because they don't understand it and they don't know where it falls in the prioritization line. So how we're presenting data to them is the problem. So what are the problems with this data? Well, mainly it's really dull. Data that we work on is really dull. It's very hard to read. It usually comes in text files. You'll probably see it in some human machine readable format, so like JSON or something along those lines. And they're often pretty large, gigs upon 90 days, right? Have everyone ever heard of that one? So that's really what gives us a big problem there. Oftentimes it requires expertise to understand. So a lot of times you need to have a person come through and parse all that data. So that scripting guy in your security group, that's the guy that's going to go rip through the logs and give you the insight that you need and apply logic to that data in order to even understand what's going on. Until then, it's just a bunch of letters and numbers that no one really cares about, just fills up space and we have to pay for storage, right? And then after that, it's really not intuitive. A lot of the different logs come from many different sources, and they have really weird and odd nomenclature sometimes. So you could see that like destination in a field of a log would be spelled out DST, or you'll see like DEST, or it'll actually say destination, or it'll say destination IPs, and I can keep going on with this. So like when you have to pair that stuff together, it's hard because some other person off the street's going to be looking at that data set and they're going to think that those are two different things, even though it's just the names that people used. Another problem is the complexity. So we can't get away with Excel spreadsheets anymore. Data is way too complex for that. There's a lot of correlation that needs to go on, and one-to-one matching just doesn't really work when you're dealing with, even with pivot tables and Excel spreadsheets. You have to sort of wrangle your data, normalize it, pull it up together in one sort of format. I think the word Splunk and Elasticsearch comes to mind, and you really have to view your data in that form. So it's just not just dropping things, a CSV into an Excel spreadsheet anymore, and we've moved beyond that. Also, when we think about some of the ways that people are presenting data in a good way, they are also doing it bad. So when people are actually looking at, oh, hey, let's graph this, they're actually using it as marketing tools instead of actually using the data and interpreting it the way that it's supposed to be. So we see commercialized tools and marketing using the functionality that we should be using as analysts and practitioners to sort of show off what they can do. And you can see this by the pew pew graph that I posted up here, which every company has. A lot of these visualizations are misleading, and they're used for marketing purposes or sales purposes. Their main goal is to convey the need for the potential customer and not really to actually give you information about the data in which they have made that graph from, and that makes it really bad. In this case, you see that this data is showing attack traffic going around the world. But using a global map is actually not really a good idea for this because their data is based off of target traffic from their clients and then also data from their sensors. But that's really biased towards where they put their sensors. So if I have all my sensors in China and I make a pew pew graph, you're going to see a lot of pew pews in China versus everywhere else. So a realistic and more practitioner-focused way to visualize this data would actually be to pull out the country information and actually look at the data traffic in of itself. So more focusing on the ports that are used and the type of attacks and techniques that are used. So making, some sort of graph or chart or diagram that would say, these are the type of attacks that we're seeing per sensor versus China's getting attacked. Look at these pew pews. So the question is, and the goal for my presentation is a public service announcement of how do we fix this. We cannot keep letting the marketing team and the salespeople make our graphs for us because they're going to misinterpret it. They're going to make it look very, very, very auspicious of what we're trying to give it. And we're actually better suited to present this data and give the perception that we need because we worked on it. We did the analysis. So through this talk, I want to talk about the different techniques of how to pair these threat data models with graphs, and then also help articulate what the data is doing with incident responders and analysts. I think that we should think of this as a perfect service announcement because definitely something that we need in our industry. You see a lot of these graphs and a lot of this stuff coming through vendors. So if you work for a large vendor, you'll see, oh yeah, my dashboard looks sort of like that. But you're not making that dashboard, and that's the problem. And also when you're working in-house for a company, a lot of those dashboards are coming from your vendor, but they don't know you. And that's not tailored towards your environment. So inherently, one tool can't fix all your problems. You have to make these things correlate to what you have in your environment. So why do we want to do this? Well, things are boring, right? Like that is a report, a forensic report. Who wants to read that? Nobody. After I write those, I don't even read them. And I'm guessing half my clients don't because I show up again three months later doing the same thing with the same recommendations. But when you have reports that have really cool, nice graphics, those are exciting. Like that actually brings your attention and draws your attention to the points that they're trying to make, and those are more helpful. That's why when you see the data breach reports and the global threat reports and all of these cool things where you have You have characters that characterize threat actors, or even your exploits have their own logos and music videos. This is why we do it. It's because it wants to draw your attention to what the important details are. They want to lean you towards what they're trying to say versus, having you go through the whole rigmarole of reading the report and trying to understand the analysis that the analyst did. If you do have visualizations in your report, they're more likely to agree with you. You're more likely to get a positive feedback and actually get them to do your recommendations because they'll actually see what they need to do versus you just telling them, oh, you're messed up right now. You really need to do X, Y, and Z. They'll step back and say, oh, we're really messed up. We need to do X, Y, and Z. That's a better sell. You want your points to be like a slap in the face. So you want it to where whenever you're going to your audience, when they say how bad it is, you slap them and say the data's already leaving your network, because that's exactly how it should feel when they look at your reports. They need to know exactly what needs to happen and what they should be doing and what went wrong so that they can action appropriately, because the bad guys are already winning. They already stole your coffee maker and walked out the door. So the faster you get to action, the better your results you'll see. Another reason why visual input is often better than just reading or hearing. 10% of knowledge comes from what we read, but 30% comes from what we see. I like those odds. They're more likely to see the point in what you're doing when they actually can put their eyes on something and look at visualization and follow it. So here's where we start with some of the concepts that we should be using as security practitioners to help guide our audience to the data that we're trying to present to them. And these are called the Gestalt principles. And these are only a couple of them, but I thought that these were pretty appropriate to my examples later on to sort of show you the different ways that you can use your data and visualize your data in order to give perceptions and drive customers or clients or coworkers to, this is what I'm trying to show you. So the first one is proximity. Naturally, as humans, when we look at something, the things that are closer together feel like they should be together, so they get grouped in our minds. So in the first example, you see all three, just equal spacing apart. But in the second example, you see that there's two distinct groups, and that's just from our perception, we automatically put those buckets together. So when you're grouping things and you want to say, these are different from this, servers, workstations, when you put a little gap between them, put a little white space in between them, it actually differentiates them to whoever's reading or looking at what you're doing, so that it feels like there's two separate things that you're looking at. The next thing is common fate. So naturally, we try to make lines and flows throughout what we're looking at. So those two boxes, the left and the right, actually both should look like they're a path. One's straight and one's squiggly. And our eyes are supposed to follow that. So when you're doing things like, looking at charts or making, diagrams or anything along those lines, looking into how the correlations look will really help tailor what your perception and what type of definition you're trying to put upon your data. Similarity. When things all look the same, they are the same. But when there's a clear difference, like with the last two dots, those get called out. So it's almost like putting a space in between them. Figure ground, bolding out things. One of the biggest things that helped our reporting out was that we would bold, turn red, and if we were in GIFs days, we'd have flashing colors, the risk level of different things. And so naturally, when our customers would look at reports, they would just skip to the risk page and they'd just look for red, green, and blue, and all the colors of the rainbow. And they would just work on that. So they would focus on the things that really were alarming to them, and that really helped out. So whenever you make something that calls out, like is definitely bolded or abstracted from the rest of the background, people's eyes naturally focus to that. Continuity. So the lines that look more smooth and natural are the ones that you're going to probably follow. So they like to follow a certain path. And this is really this really makes sense when you're looking at like a regression line on a scatter plot. The reason why they make that straight line across the scatter plot is because looking at the dots confuses you. You don't know the trend until you see the line, the continuity line that tells you where the trend, where the data is going. The last one is symmetry. So things that look feel the same object, and they're around the same shape, those will often be similar type of objects. And those are basically the perceptions that we're going to use later on to help build visualizations to give threat data that would be more meaningful to your audience. So as you could probably tell by the talk, graphs are a good way to use these concepts. And we actually have a lot of graphs in our repertoire currently. I think that every report has a bar graph of some sort, a line graph, and a pie graph. Those are things that's our jam. We stick into that level. But we need to broaden because the world's getting more dynamic. The data's getting more dynamic. There's relationships that don't inherently show when you do a bar graph. Like top talkers, bar graph, good job. But like when you have different types of data sources and they're coming from left and right and east and west, and I pointed in the wrong directions there, but it's all right. Then those are where you're actually going to have those dynamic graphs really help out because they actually can do multiple concepts and convey different relationships than these traditional graphs. So we're going to try to add some of those to your repertoire right now. So we're going to go over 4 different new graphs and how they compare to threat data and give you examples of how those things would be, used in a report or a security analyst setting. And hopefully by the end of this, you'll have some ideas to take your own data and visualize them in this new way. So the first one is a tree map. So a tree map is actually it plots a series of data over time, like around itself, and it really throws things into buckets. This is really used for predicting past and future trends. A good example for this is using network logs. The concepts that this would use would be similarity and symmetry. So when we look at this, if you had network logs and you want to figure out a way to understand what type of data is coming across or transferring across your network and where it is going, you would want to use a map like this. And right here we have a map. It's the map for outbound connections by country and port. So the biggest thing you're going to notice here when you're looking at this graph is that each country is a different color. That's really easy because we can actually just look at it and say, okay, we have like a large amount. And then you have a section of countries at the bottom there. So most of the large sections are different colors. You can see that the squares will show the different types of the similarity because of the color change, but then the symmetry, there's smaller squares within this. If you look up there, where you can see that each one of those green squares all mean the same country, and then the smaller squares are a subset of that where it shows different ports that are going to be used. And you don't even have to really see the data. Like we don't see all of the traffic or all the data from here, and you actually don't even need to see the ports. Because when you're looking at big blobs of colors and little squares, like we've done that since we were 2 years old. So we know how to differentiate, the black from the green from the orange. And we also know that if we look at this graph, we can say that Taiwan, which is black, Korea, green, and China, orange, makes up half of the outbound traffic for this environment. That's something you could do every day within 2 seconds. You probably can't even read the ports on here. And you probably can't read like the different intricacies between the bots, but that's something that on a quick glance, if you throw it up into your SOC dashboard, you'll be able to tell what's going on, especially over time when that actually changes. So say, you experience attack from a certain country and that blows up. You're gonna see that square getting overrun by different areas and the different colors. So you would have a traditional color palette that you'd be used to, and then as that changes over time, it just will insinuate that there's a change in the amount of traffic that's going to different places in your environment. So as you can probably tell, the size of the blocks roughly compare to the percentage of data throughout the whole traffic stream or whatever time span this data set was from. And basically, you can sort of tell the percentages from that. You can also see that large portions are a lot different from other large portions. So in orange, you can see that there's two large squares. The one on the left is actually telnet traffic, and the one on the right is SMTP traffic. But in all of the larger boxes in every single one of those squares is telnet traffic. So from there, you can derive that there's a lot of SMTP traffic going out to China. This could be from a situation like you have a spam bot that was targeting Chinese companies or something along those lines, and it's sending out traffic there. So if you were in an incident standpoint and you had a spam or malware and you saw this graph, you would be able to tell right away that there is a disproportionate amount of SMTP traffic going to China. And if you weren't a company that was within China or does business in China, that would be alarming. Your boss would be able to see directly why that's a problem. Everyone could. I even think a 3-year-old could, because we used to play that game with the blocks and the colors and all that stuff, and it worked out really well. So this really gives you a good heads up. It gives you a really quick way to understand and look at a large amount of data. If you were to look at this in a data table, it would take forever. You'd probably want to make a lot of lists and charts. So you'd be making bar graphs of the amount of traffic for each protocol. So you just have lines of bar graphs going down your screen. You probably have, that archetypal color map and numbers from each country and all that stuff. So like you just consolidated all that in one graph here. The next one is the chord diagram, and this is actually one of my favorites. This visualizes interrelationships between entities. The entities are arranged around the circle, and then they have connections between them called chords that show a relationship between that entity to another entity. The reason why it's a circle is sort of like the parachute game where you had to run back and forth, is that all the entities are encompassed in that circle, and that shows the whole corpus of data that you're dealing with. A good example of this is also network logs. And the concepts that this use is common fate and figure ground. And this is a chord diagram. And once again, you can't read any of the data, but you can obviously see something's going on. You know why? Because it's red. And that is the figure ground that's speaking there. So because there's a big differentiation of the traffic that you want to look at and the traffic that is the rest of the traffic in the environment, you can tell that red is bad and it's spreading everywhere. That's scary, right? If you showed anyone that, they would know that there's something that they have to deal with, and it has to deal with it n amount of times based on how many red endpoints are touching right there. So what this graph is this graph is actually a map of port 20 connections from a specific host to other areas of the network. So the entities around that circle are IPs of other hosts around the network, and then ports from the target host. So this would be used in a case where you are a SOC analyst or a forensic analyst, and you were looking at logs and saying this host was connecting out somehow to a bunch of things. Did it connect or laterally move through within our environment? So you'd basically look at all the logs and you'd say, what ports is it connecting on to other computers, and what other computers is this communicating with in our environment? And this will show it. Because of that tree, the bottom of the tree there is port 20, and then it's reaching out to numerous amounts of other hosts. You can see sort of the density of some of the traffic, even like some of the other ports. So you could see port 80s coming from the side, and if you could see like port 443 and some of the other common ports, you can see that has a lot of traffic out, and it's interconnecting pretty well there. Also, what makes this graph really, really usable is that you can actually see that, if you know port 20 is the malicious port, or probably is the malicious port, you could see how other ports are affected by the environment also. So does this computer or host connect to other computers naturally? Is it just like a high talker? Is this something normal? Well, you can compare that in one graph, and you're having a large amount of dynamic data to sort of help out with that. The next one is a Sankey diagram. So this shows the amount of data that's flowing through thickness pipes and it helps determine like the throughput of a system or lack thereof. So there's a really good example for this for web logs. So you want to see where the traffic's going in your website. You could use a Sankey diagram to do this. It uses the design concept of a symmetry, and it really just helps you understand the web flow of your logs, the flow of your web logs. So here's a Sankey diagram, and this is actually of a web app server. So basically, think about your access logs being ingested and turned into this. This is way better than reading web access logs, and you can see the chain of connections and how people are traversing your website. So some things to point out here is the symmetry comes from the sizes of those pipes and how they're getting broken up. So most of the traffic that you see starts out with a login, but then there's some things that are alarming here. So someone may be able to bypass the login with that little red line there that's pushing all the way to a search area. Like that would be something that a pen tester or a security auditor would want to find out. And this map actually clearly shows that. If you sent this to a boss or some sort of audience to look at, you can sort of akin it to Chutes and Ladders. How do we get to the end here, and what's the easiest path? Login, well, that door's locked. But that red slide down there, you could slide right back into your search area, and that gives people the keys to the kingdom. Another thing that you can point out is that most of the traffic is going towards two places, and they're both searches, and that makes sense. So you can sort of get a baseline of where your traffic's coming from. This is really useful for a lot of things. I mean, even if you wanted to talk about where your users and data flow is going to for performance standards, that's a really good graph for that. But for security, when you're looking at web access logs for intrusions, you can look at SQL injections and see where the most weird path to things are, or even with DDoS. You can actually take the patterns in which people are doing like DDoS attacks and map them out and say, all right, these are DDoS attacks. Another really good example is web scanning. So typically web scanners have a set of things that they're checking on a website. And if you see those patterns, you can actually identify what scanners are actually going and the volume of those scanners versus other scanners. So that would give you a good delineation of what you're dealing with. The last graph here is a network chart, and this shows interconnections between nodes, and those are represented by links. And a good example for this, and I think network charts is on the par of one of the most used visualizations for InfoSec, is process execution chains. And this uses the concepts of continuity and proximity. So you can see that this is actually a process chain from the Petya malware, which is ransomware. And each one of those nodes represents a different process being generated or a different action by the process of that malware. So instead of just telling your boss or your audience that you were infected by this file, which is one thing, they actually see the activity that it's doing without the network, and that looks a lot more intimidating than just a doc file that tells you you have to pay or you have a UPS shipment or something along those lines. It uses the proximity, so the ones that are closer together are actually in the same cluster of activity. So you can see up at the top there that those are together, that stream, and then the other processes are on the side, and then they all join from the parent process. And then continuity. Some of the longer processes are things that you're going to be concerned about, and actually those are pretty concerning things. So there's a persistent mechanism where it does the scheduled tasks, and then also there's another file that gets dropped, which is an IFC. This is really good to show the different dynamicness of things, because typically you want to respond to things when you're seeing them. So when you're doing a malware response, like not Petya or Petya, you would want to just, all right, let's clean up everything that's going on. Well, if you just told them that this file was the problem, some people might just get rid of that file and they not do anything with it. But when you see that it spawns like that many processes, which are probably encrypting your hard drive as we speak, and then they're doing all these persistent mechanisms, it shows the activity of the malware, and it says that it's a little bit more in depth than that. That's one of the hardest things I think that I had to get over, is that I needed to make sure that I conveyed to my clients that cleaning up malware takes a village. Instead of just going in and just deleting whatever I told them, there's other things that may happen. There might be reformatting that's going on. So in all, showing something like this sort of builds a larger sense of urgency. It gives them an idea of how dynamic the malware is. So if there was something that only did one thing, they might be more comfortable to do the lower level response. But when it's rolling out a bunch of processes, you really want to make sure you address it appropriately. So in the end there, visualizations help convey your point, and you need to use them. And that is the end of my talk. Any questions? Yep. Oh yeah, definitely. Well, there's a lot of different ways to do that. So Splunk will actually do a lot of that stuff, and you won't even have to use libraries. Elasticsearch Kibana is really helpful for it. Pandas is really great. I usually use Seaborn, the Python library, to make those visualizations. There's actually a website called Python Graph Gallery that will help out. That's actually where my icons came from. That will help out with those. The point is, you can actually draw these too. Like, I mean, a lot of this data is, they're supposed to just convey a meaning, and that's really where we're missing in the whole helping the world aspect, is that, why don't they listen to us? Well, because they don't understand, and we have to make them understand. So when we can do things like convey an actual meaning from the graphs that we make, instead of scaring them with a panda cartoon like that, those are the type of things that I think really help out our community. Cool. All right, well, thank you very much, guys, and have a good night.